Lay's potato chips are one of the most recognizable snacks in the world. Thin, golden slices with a precise crunch, consistent flavor, and unmistakable texture. Yet behind every bag lies a massive industrial food operation built to handle thousands of tons of potatoes with extreme speed, hygiene, and precision. What seems like a simple fried snack is actually the final result of agricultural planning, optical sorting, high-speed slicing, continuous frying, real-time moisture control, automated seasoning systems, and non-stop packaging lines designed to deliver identical chips to millions of consumers every single day. And today on The How Factory, we're going inside modern Lay's production facilities to see exactly how potato chips are made. From raw potatoes harvested in fields to crispy chips sealed inside bags and shipped worldwide. The journey begins long before potatoes ever reach the factory. Lay's works with contracted farms that grow specific potato varieties selected for chip production. These potatoes are bred for low sugar content, uniform size, and high dry matter, which helps produce light-colored chips with a clean crunch. Farmers carefully manage irrigation, soil nutrients, and harvest timing to ensure potatoes meet strict specifications. Once harvested, potatoes are stored in climate-controlled facilities, where temperature and humidity are carefully regulated to prevent sprouting or sugar buildup. When needed, truckloads of potatoes are transported directly to chip factories, often located close to growing regions to reduce transit time. As potatoes arrive at the factory, they are unloaded onto receiving conveyors and immediately inspected. Dirt, stones, and plant debris are removed using vibrating screens and air separators. The potatoes then pass through optical sorting systems equipped with high-speed cameras and sensors that analyze size, shape, and surface quality. Potatoes that are too small, damaged, green, or misshapen are automatically diverted for other uses or discarded. Only potatoes meeting exact standards move forward because even minor defects can affect frying quality and final appearance. Once sorted, potatoes enter the washing stage. Large rotary washers and water flumes scrub the potatoes thoroughly, removing soil and surface contaminants. High-pressure sprays and rotating drums ensure every potato is clean. Cleanliness here is critical. Any remaining dirt could burn during frying and contaminate the oil. After washing, the potatoes are visually inspected again before moving to peeling. Peeling is performed using steam peelers or abrasive systems. In steam peeling, potatoes are briefly exposed to high-pressure steam that loosens the skin. A rapid pressure release causes the skins to crack and separate from the flesh. Rotating brushes then remove the loosened skins with minimal loss of usable potato. This method preserves yield while ensuring smooth surfaces. Peels are collected and often repurposed as animal feed or compost, minimizing waste. Immediately after peeling, potatoes are sliced, one of the most critical steps in chip production. High-speed slicers use razor-sharp rotating blades to cut potatoes into perfectly thin slices, often less than 2 millimeters thick. Slice thickness directly affects texture, oil absorption, and cooking time. Sensors monitor blade wear and slicing accuracy continuously. If slices become too thick, chips turn chewy. Too thin, and they burn. Precision here is essential because thousands of slices are produced every second. Freshly sliced potatoes fall directly into cold water baths to rinse away surface starch. Removing excess starch prevents slices from sticking together and promotes even frying. The water flow is carefully controlled to keep slices separated while minimizing breakage. From the rinse tanks, slices move onto vibrating conveyors that remove excess water before frying. Frying is the heart of the Lay's manufacturing process. The slices enter massive continuous fryers filled with carefully filtered vegetable oil, typically sunflower, corn, or canola oil depending on region and formulation. Fryers operate at temperatures around 175 to 190 degrees Celsius. As slices move through the oil on mesh belts, moisture rapidly evaporates from the potato, creating the characteristic crisp texture. Frying times are measured in seconds, but the process is tightly controlled. Oil temperature, flow rate, slice density, and belt speed are adjusted constantly using computerized systems. During frying, moisture content drops from roughly 80% to just a few percent. This transformation is monitored in real time using sensors that measure color, moisture, and oil absorption. Chips that cook too long become dark and bitter. Undercooked chips remain soft and greasy. Automated controls make instant adjustments to maintain consistent results despite natural variations in potato composition. After exiting the fryer, chips pass through de-oiling stations where excess surface oil is removed using vibrating screens and air knives. This step helps control fat content and improves texture. At this stage, the chips are fully cooked but still unseasoned. Next comes seasoning, where Lay's signature flavors are added. Chips move through rotating seasoning drums while fine powders or liquid flavorings are applied evenly across the surface. These seasonings may include salt, spices, cheese powders, onion blends, or proprietary flavor compounds depending on the product. The timing and application rate are precisely controlled, so every chip receives a consistent coating. Even distribution is critical because uneven seasoning leads to customer dissatisfaction. Flavor development is a science in itself. Lay's flavor formulations are designed to adhere to hot chips, dissolve slightly in residual oil, and deliver a balanced taste with every bite. Humidity, chip temperature, and drum rotation speed all affect how seasoning sticks. Quality teams constantly monitor flavor intensity and adjust dosing systems in real time. Once seasoned, chips enter cooling tunnels. Cooling stabilizes texture and prevents condensation inside packaging. Airflow systems gently reduce chip temperature while minimizing breakage. Chips are extremely fragile at this stage, so conveyor transitions are designed to be smooth and shallow. Broken chips are separated and often repurposed for other products. Quality inspection intensifies before packaging. Chips pass under optical scanners that detect color defects, burnt pieces, or foreign objects. Any chip that does not meet appearance standards is automatically removed using air jets. Random samples are also taken for taste testing, texture analysis, and moisture measurement. Lay's maintains strict quality benchmarks to ensure consistency across every bag. Packaging is one of the fastest operations in the factory. Chips move directly from cooling conveyors into vertical form-fill-seal machines. Bags are formed from printed film, filled with a precise weight of chips, and flushed with nitrogen gas before sealing. Nitrogen replaces oxygen inside the bag, protecting chips from oxidation and breakage while keeping them fresh and crisp. This is why Lay's bags appear partially inflated. The gas acts as a protective cushion during transport. Each bag is sealed, date-coded, and checked for weight accuracy. Underweight or overweight bags are rejected automatically. Vision systems verify seal integrity and print quality. Finished bags then move to secondary packaging, where they are grouped into cartons or display-ready trays using automated case packers. From there, robotic palletizers stack cartons onto pallets, optimized for shipping efficiency. Pallets are wrapped, labeled, and scanned into inventory systems. Because chips have a limited shelf life, logistics planning is critical. Distribution centers coordinate deliveries so products reach stores quickly and rotate properly. Behind the scenes, oil management is a constant focus. Frying oil is continuously filtered to remove crumbs and maintain quality. Oil chemistry is monitored closely to prevent degradation that could affect flavor or safety. Used oil is replaced on a schedule and recycled responsibly. Water used in washing and rinsing is filtered and reused where possible. Food safety standards in Lay's factories are extremely strict. Facilities operate under continuous sanitation programs. Equipment is cleaned using automated clean-in-place systems. Air quality, temperature, and humidity are controlled in production zones. Workers follow hygiene protocols, including protective clothing and controlled access. Every step is documented for traceability. Sustainability also plays a growing role. Lay's factories work to reduce water usage, improve energy efficiency in fryers, and minimize food waste. Potato byproducts are reused, and packaging materials are continuously redesigned to reduce environmental impact while maintaining freshness. What makes Lay's chip production remarkable is the balance between natural variability and industrial precision. Potatoes are agricultural products that change with seasons and soil, yet every chip must taste and crunch the same. Achieving that consistency requires constant monitoring, automation, and real-time adjustments across dozens of interconnected systems. From fields of potatoes to high-speed slicers, from roaring fryers to nitrogen-filled bags, the journey of a Lay's chip is a tightly synchronized industrial process operating at massive scale. Every crunch is the result of chemistry, engineering, and logistics working together invisibly. And that is exactly how Lay's potato chips are washed, peeled, sliced, fried, seasoned, cooled, packaged, and shipped, transforming raw potatoes into one of the world's most iconic snacks. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the machines, systems, and factories behind everyday products.